Okay, so the objective in this lesson is to solve rational equations. This corresponds to 6.5 in your Math 3 textbook if you want to refer to the textbook and look at any further additional examples. All right, so first of all, what is a rational equation? I wrote over here that's an equation that has a variable in the denominator. Okay, so just because you have a fraction doesn't mean it's a rational equation, but the variable has to be in the denominator. Okay, so take a look at this first example. State, if any, excluded values. And over here, I'm going to abbreviate excluded values in the notes as EVs. Okay, and your excluded values are anything that makes your equation have a denominator of 0. And so if you take a look at this very first problem, this is actually a linear equation, right? Remember the definition of a rational equation is that the variable has to be in the denominator. So this is actually linear, okay? All right, so now that we've established, okay, this is actually a linear equation, what are we supposed to do? You can combine the like terms here on the left side of this equation, right? Subtract these two fractions and then maybe cross multiply, but that's actually too much work. And what you're really supposed to do over here to make things easier for yourself is to multiply the whole equation by the least common denominator, otherwise known as your LCD. Okay, so over here, let's go over our LCD again by doing the prime factorization tree. 8 is 2 times 2 times 2. 10 is 2 times 5. And then, right, if you circle your common factor, use that 2 once, multiply by what's left, 2 times 2 times 5. And so right away, you get an LCD of 40. Once you establish what the LCD is, what you want to do is distribute the LCD into the entire equation, okay? So just be careful when you distribute and what cancels out. Let's start with this first term right here, 40 times this term. Remember, treat this as a single term, so I'm going to put parentheses around here. Notice that 8 actually goes into 45 times, okay? So 1 over here, and then this becomes a 5, and then distribute. Okay, so over here, you can write 5 times 5 plus 7x. I'm going to show you the distributing on the next line. And then distribute 40 into the second term over here. And when you distribute 40 into the second term, right, 10 goes into 40 4 times. Okay, so I'm going to cross that off. That becomes a 4. And then 4 times 3 is 12. Parentheses x plus 5. Okay, last but not least, make sure you distribute 40 into this last term. 40 times 2 is 80. And what looked really intimidating in the beginning right here actually just turns into a nice linear equation. Okay, so from here, distribute combine like terms. You're going to get 25 plus 35x. Subtract 12x. Subtract 60 is equal to 80. 35 take away 12 will give you 23x. And then 25 subtract 60 will give you minus 35. All right, so add 35 on both sides, and you're going to get 105, and x is actually equal to 5. Okay, so I explained to you what EVs are, right? Anything that makes your denominator 0, but because there was actually no variables in this problem in the denominator, our EVs, our excluded values, are actually just none. There are no numbers that are going to make my denominator 0 because there is no variable in the denominator. So this first example, while it had fractions, is actually a linear equation. But the process of solving all rational equations, any rational equation or anything that has a fraction is the same. You multiply the whole equation by the LCD. So let's take a look at the second example over here. All right, so over here, we have 7 over r plus 2 is equal to 6 over r minus 5. All right, so this one, right, if we state the EVs, anything that makes our denominator 0, right, we simply set r plus 2 not equal to 0. And if you solve, r can't equal negative 2, right? And we set r minus 5 not equal to 0. R cannot equal 5. So these are your excluded values. Why are they excluded? Because if r were negative 2, right, negative 2 plus 2 would be 0. Or if r were positive 5, 5 minus 5 would equal 0. So the key is, as I solve this, right, make sure the solution that I get is not part of my excluded values. Okay, so if I get a value of r equals negative 2, r equals 5, I must exclude it because we know we can't divide by 0. All right, so notice there's a single term here on the left, single term on the right. The easiest way to approach this problem, I'll show you way one, is just to simply cross multiply. But make sure you put parentheses treat it as a single term. So if you cross multiply, right, that's going to be 7 times parentheses r minus 5. And if you multiply this term right here, that would be 6 times parentheses r plus 2. So that would be the easiest way. If you want, you could approach it way 2, which is using the LCD. Okay, the LCD in this case is just r plus 2 times r minus 5. And it's a little more work in my opinion, but you'll get the same exact result. So over here, if I rewrite the same problem, and I multiply this entire thing by the LCD, you will get the same result, right? If you distribute r plus 2, r minus 5 into this term, the r plus 2's will cancel out, you'll get that. If you distribute this term into here, the r minus 5's will cancel out, you'll get 6 times r plus. Okay, so way 1 is probably the way to go, which is the cross multiply. And you can only cross multiply when you have a single term on both sides. So, all right. Continue by solving this problem by combining like terms and distributing and simplifying. You're going to get 7r minus 35 is equal to 6r plus 12. Combine your r's. If I move the 6r over, I'm going to get 1r. And then if I add 35 to both sides, I'm going to get r equals 47. Okay, so way 1, just cross multiply when you see single terms on both sides. And notice the solution I got is not part of the EV, so I'm good to go. You could always check it if you want, but it's not necessary since it's not part of your excluded values. All right, moving on. Example 3. W plus W over W minus 1 is equal to 4W minus 3 over W minus 1. Okay, so right away, let's state the excluded values. You should do that first. W minus 1 equal to 0, therefore W cannot equal positive 1, right? Because if I have a value of W equals 1, that would make my denominator 0, and you know that you can't divide by 0. Okay, so again, there's a number of ways you could solve this, right? You can try to combine like terms here on the left side, add the two fractions, and then cross multiply. But the easiest way is just to multiply the equation by the LCD of all your denominators. So in this case, my LCD is just W minus 1. And so let's multiply the whole equation by the LCD. Okay, so I'm going to put it here on the right. It doesn't matter which way you put it, whether it's on the left or right, but just make sure you distribute to all three terms. Okay, so if you multiply W minus 1 times this first term right here, it's just W times W minus 1. If you multiply W minus 1 to the second term over here, notice the W minus 1's will cancel out. You're just left with a single W. And last but not least, if you multiply W minus 1 into this term, the W minus 1's will cancel out right there on the top and the bottom. You're just going to get 4W minus 3. All right, so this time when you combine like terms, it looks like you're going to end up with a quadratic, a W squared minus W plus W. Looks like those W's will cancel out. And let's move the remaining two terms here to the right side of the equation. So subtract 4W plus 3 is equal to 0. And then you actually end up with a nice factorable trinomial. Okay, so W minus 3, W minus 1 equal to 0. You're going to get W is equal to 3 or W is equal to 1. Now, if you look right here, right, one of these solutions, W is equal to 1, was actually part of your excluded values, right? And you know that W can't equal 1, right? So if this is an EV, this is an EV, then we have to exclude it. Let's cross it off, okay? So the only solution in this problem is W is equal to 3.